Okay, some examples practicing our exponent rules. So we're going to go through some quick examples, and as you can see at the top we have our exponent rules, most of them listed out. Let's begin with 5x cubed times 3x to the fourth. Not too bad here, everything's multiplied together. We're allowed to rearrange things because of the commutative rule of multiplication. So if you wanted to, you could rearrange this and put the constants together, the 5 and the 3, and then put the x's next to each other as well. Just rearranging, sorting that out in a different way. All right, then we're allowed to multiply the constants. 5 times 3 makes 15. With our x's, this is going to be that first rule in the very top left where we add our exponents together. So 3 plus 4 is going to make us 7. On the next one in the middle, what we want to do is we have an exponent on the outside. So it's important to think where everyone messes up here is they forget that that negative 2 has its own exponent. So what we're going to do is we're going to actually apply that exponent from the outside to each one of these exponents from the inside and multiply together. So it's going to be 1 times 3. It's going to make a 3 for our exponent on the negative 2. And then it'll be y raised to the 4 times 3 power. All right, simplifying this down, remember we're going to have 3 copies of a negative 2 multiplied together, so that's going to make a negative overall because it's an odd number, negative 8, and then y raised to the 12th power. All right, moving over to the right, we have our z to the 13th over z to the 5th. Now this is our subtraction rule, the middle one up here at the top. How I like to think about this when we have the same variable in numerator and denominator is I ask myself the questions, where do we have more and how many more? So we have more in the numerator, so we're going to have z's left up in the numerator, and we have 13 minus 5, we have 8 more up in the numerator. All right, down to the bottom left. On this one, what we can think is we have everything's multiplied together is first of all the important thing. We can split this up if we wanted to and make this 9 divided by 3, x to the 7th divided by x to the 4th, and y to the 10th over y to the 3rd if we'd like to. Now we don't have to rewrite it like this if we don't want to, but this is how I'm going to think about it as 3 individual little problems along the way. So 9 divided by 3 makes 3. X to the 7th over x to the 4th, we have 3 more copies up in the numerator, and with the y's we have 7 more copies up in the numerator. Now everything's still multiplied together as we go on that. All right, the middle one here at the bottom is probably the most difficult. What we want to do in this case is I would work with the exponent first, that 5 that's on the outside, bring that to the inside first. Remember that the 2 has an exponent and the 1 has an exponent initially. So bring along the x to the 7th, and then that'll be 2 raised to the 1 times 5 makes 5 for its new exponent, and x to the 5th power as well, over x to the 3rd. Now we can work this, we can either rearrange it and put the x's in the numerator next to each other, or we can just think to ourselves, those need to be added together. It's that very top left rule. All right, so 2 to the 5th, that's 5 copies of 2 multiplied together, is going to give us 32. And then we get x to the 12th power over x to the 3rd power. I added the exponents to combine those together. We can reduce this just a little bit further because we have x's both in the numerator and denominator. So this is going to be that subtraction, or asking where do we have more and how many more. So 12 minus 3 makes 9 more up in the numerator. So our final answer there is 32x to the 9th. Finally, over on the very bottom right, we have x raised to the 1/3 power, and that's all raised to the 2/5 power. So in this case, when you have an exponent on the outside, what we want to do is multiply our exponents together. So that's going to be x to the 1/3 times 2/5 power. From here, we're going to multiply our numerators together and multiply our denominators together to get our final result. All right, this is written as a rational exponent. If you were asked to rewrite this with a radical involved, what we're going to do is use this rule up in the very top right that tells us the numerator is going to go as an exponent, while the denominator of this rational exponent goes as the index on our radical. So that's going to give us 15 as the index on our radical, x to the 2nd power. All right, hope this helps out as you're working with exponents. It really just takes practice and getting used to these, but it's a really important skill moving forward to get these down. Good luck.